Okay, see here. Now, you know here, in last you studied there various kinds of function with their geometrical interpretation. But in this lecture to study here, the next kind of function with their geometrical representation. So y is equals to a raised to x for a is greater than 0 and a should be other than 1. Okay. So value of a is greater than 0 means what? It should be positive and other than, yes, it should be positive and other than 1. Okay. So if you are taking there 1, so 1 raised to x is 1 always, am I right? Hence, condition is given e is other than 1. Okay. Now for exponential function, y is equals to e raised to x, where e is equals to e. When you substitute there e is equals to e, so get their exponential function. Okay. So do you know the value of exponential? You can get this value by calci also. 2.71828. Okay. It's a approximate value of exponential. Now, when you are taking their values of x from, yes, see here, from minus infinity to plus infinity. Okay. So what is that? Y is equal to a raised to x. So y is equal to a raised to x क्या मिलेगा आपको? देखो ये मिलेगा. So when you substitute there x is 0, that is a raised to 0, it is 1. Means what is that point which is on y axis? That is 0, 1. Okay. And then you take the values of x which are greater than 0. Okay. And less than 0. So all points will lie on that same curve. बरोबर आहे ना? हा कर्व आहे लक्षात घ्या. या कर्ववरती काय मिळतील? सगळे पॉइंट्स मिळतील. In similar fashion, substitute there, yes, various values of x which is from minus infinity to plus infinity. Am I right? So all points will lie on that same curve. Okay. So it is, you know, here when you substitute there x is 0, e raised to 0 it is also 1. Means these two curves will intersect at point 0, 1. Okay. These two curves will intersect at point 0, 1. But you know, there a should lies in between 0 and 1. A should lies in between 0 and 1. So this is what the graphical representation of exponential functions. That is index function, we can say. Okay. Now you come in there next. That is logarithmic function. Y is equals to log to the base a x. What about the e? E should be greater than 0 and other than 1. And for all x belongs to 0 to infinity. Means what? X means what? X taking their values, it is from 0 to infinity. All right. So what is that graphical representation for logarithmic function? So y is equal to log of x to the base 8. Now when you substitute there x is 0, okay. So log of 0 to the base 8. काय मिळणार तुम्हाला सांगा? Log of x to the log of 0 to the base 8. This, so when you substitute there x is 1. X is 1 means what? Log of 1 to the base 8. You know here a raised to 0 is 1. Means log of 1 to the base a is 0. Means 1, 0 is the point. Okay. 1, 0 is the point. Now this graphical representation for e is greater than 1. Okay. And when a lies in between 0 and 1, get their same curve like this. So this is what the same curve. Now these two curves for logarithmic function, but depends on their a. If a is greater than 0, greater than 1, like this, means it lies in their first quadrant as well as in their last quadrant. Am I right? So get their exponential. And what about their next? Here e lies in between 0 and 1, means this will intersect at 1, 0. Okay. So you know here y is equals to natural log of x. It means that in means what? Natural log of x means log of x to the base e. You got it clearly? And x is greater than 0. X is greater than 0. Okay. So These are the graphical representation for logarithmic functions. Okay. Now you come in there next. Okay, see here. So this was the hyperbolic sine function. Do you know their exponential function or Euler's formulae? E raised to x. How to write that e raised to x? आपण e raised to x कसं लिहितो रे? E raised to x is equals to cos hyperbolic x plus sin hyperbolic x. आणि e raised to minus x कसं लिहितो? Cos hyperbolic x minus sin hyperbolic x. If you adding them, get their term of cos hyperbolic x. And if you subtract them, get their term of sin hyperbolic x. And with respect to that, what is formula for sin hyperbolic x? So when y is sin hyperbolic x, and we know here hyperbolic function in the form of exponential, that is e raised to x minus e raised to minus x upon 2. For all x belongs to R, means x is a real. It will take their values from minus infinity to plus infinity. Okay, you got it? Now, when you substitute their values from x is equals to infinity, minus infinity to x is equals to plus infinity. For example, you know, when you substitute there x is equals to 0. So 0 is the central value of that function. Am I right? Now when you substitute there x is 0, e raised to 0, it is 1. E raised to minus 0, it is also 1. And 1 minus 1, 0. 0 divided by 2 means what? 0 divided by any finite number. It is 0. Means y is 0. When x is 0, get y is 0. Means it is at origin. Means that curve will pass through the origin, and then origin acts as a central value of that function y is equals to sin hyperbolic x. And if you are taking their values of x which are greater than 0 and less than 0, so all points will lie on that same curve. And when you join all these points, get there, the graphical representation of sine hyperbolic functions. Sine hyperbolic function. Okay. Now see the next. Hyperbolic cosine function. So this formula will also get by using the addition of Euler's formulae. And do you know their Euler's formulae? Once again, e raised to x is cos hyperbolic x plus sin hyperbolic x. And e raised to minus x is what? Cos hyperbolic x minus sin hyperbolic x. If you adding them, get formula for cos hyperbolic x. So what is that cos hyperbolic x? E raised to x plus e raised to minus x upon 2 for all x belongs to R. Now x belongs to R means what? X will take their values from minus infinity to plus infinity. Means x will take their real values. And real values are from minus infinity to plus infinity. Okay. Now, you know, here, first of all, I will discuss with you the central value of that function. So where, at which place you are getting the central value. So when you substitute there, x is 0. X is 0. So e raised to 0, it is 1. E raised to minus 0, it is 1. And 1 plus 1, it is 2. So 2 upon 2, it is 1. Means when you substitute there x is 0, get y is equals to 1. Means what is that point? 0, 1. Means vertex of that curve is at 0, 1. Okay. And 0, 1 is the central value. A central point on that graph of their function y is equals to cos hyperbolic x. Okay. Cos hyperbolic x. Now you know here, if you are taking their values which are greater than 0, means all points will lie on right side of this curve. Am I right? And when you are taking their values for x which are less than 0, all values will lie to the left of that curve. Am I right? And when you join them, get a graphical graph of their cosine hyperbolic x. Okay. cosine hyperbolic x. So this is way to define or to draw their graphical representation of function. Okay. See here, the next hyperbolic tangent function. Y is equals to tan hx. What do you know here? What is the tan trigonometric function gives us the relation between sine and cos. But actually it is hyperbolic function. Means tan hx is sine hx upon cos hx. Okay. Now you know sine hx is what? E raised to x minus e raised to minus x upon 2 upon cos hyperbolic x is what? E raised to x plus e raised to minus x upon 2. Okay. So here 2 will cancel. Okay. And for all x belongs to R means x will take their values from minus infinity to plus infinity. Minus infinity to plus infinity. Is it clear? Okay, see here. Now, for this graph, what is that central value? Substitute x is 0. In sine hyperbolic function, cos hyperbolic function, and tan hyperbolic function, we get their central value at x is 0. That you should keep in mind. Okay. So when you substitute that x is 0, e raised to 0, it is 1. E raised to minus 0, it is also 1. And 1 minus 1, it is 0. But in denominator, e raised to 0, it is 1. And e raised to minus 0, it is also 1. And 1 plus 1, 2. So 0 upon 2, it is 0. Okay. So when you substitute that x is 0, yet y is 0. Means it is at origin. It means that their graph of their function or curve of that function will pass through the origin. And it acts as a central value of that S function. Okay. So at x is 0. If you are taking their values of x which are greater than 0, so all points will lie on their right side, or all points will lie on their graph of function which is in fourth quadrant. Okay. And when you are taking their values of x which are less than 0, so all points will lie on the graph of function which is in their third quadrant. Am I right? Which is in their third quadrant. So in this fashion, we get their graph of tan hyperbolic x. Okay. So hyperbolic tangent function. So this is what graphical representation. So we have studied here the graphical representation of hyperbolic functions like cos hyperbolic, sine hyperbolic, and tan hyperbolic x. Okay. Tan hyperbolic x. Yes. See here the next. So after studying here the theoretical as well as graphical representation of various kind of function. Next to study here the limits of function. So you go anywhere, limit is important. If limit is not there, it is limitless. Okay. So there is need of limit. Okay. See here. So functions are f of x and g of x. And argument is x. A real constant a and k. So a and k are constant. Okay. So what are the results? Your formula is in limits. Okay. So first formula is that limit to f of x plus g of x as x tends to a is nothing but limit to f of x as x tends to a plus limit to g of x as x tends to a. It means that limit of sum of function is nothing but sum of their limits. Okay. In similar way, to apply the limit of subtraction of function, limit to f of x minus g of x as x tends to a is limit to f of x as x tends to a minus limit to g of x as x tends to a. Means limit of subtraction is nothing but subtraction of their limits. Okay. Now in the next, product of functions. if product of functions are there on which how to apply their limit. So limit to f of x into g of x as x tends to a is equals to limit to f of x as x tends to a into limit to g of x as x tends to a. What does it mean? It means that limit of product of functions is equals to product of their limits. You got it? Product of their limits. One more result is there. Hmm? So limit to f of x upon g of x as x tends to a. So what is that limit? Limit to f of x as x tends to a upon limit to g of x as x tends to a, provided limit of g of x as x tends to a should be non-zero. Condition is given. Under this condition, this result will exist. Otherwise, no. Suppose limit to g of x as x tends to a is 0. Yes? What is that limit? What is that limit? जर समजा लिमिट ऑफ जी ऑफ एक्स एज एक्स टेन्स टू हा 0 होत असेल तर व्हॅल्यू काय मिळेल रे? येस, व्हॅल्यू काय मिळेल? एनीवन? व्हॅल्यू काय मिळणार? सो what is that value when g of x limit to g of x as x tends to a is equals to 0? Their limit will be, yes, काय असेल सांगा? इन्फिनिटी असणार. So any finite number divided by 0, it is infinity. It is meaningless. Hence, condition is given limit to g of x as x tends to a should be non-zero. You know here, limit of division of functions is equals to division of their limits. Division of their limits. Now here in limit, whenever you go, if there is function, you apply their limit. You apply their limit. When their functions are in addition, or in subtraction, or in multiplication, or in division, you apply their limit to functions. Okay, you got it? Then next, limit to k into f of x as x tends to a. What is that k? K is constant. K is constant. So when k is constant, take it outside and you apply the limit to functions only. If there is x, you apply the limit as x tends to a. Okay. If no term of x is there, that is constant, take it outside if possible. Okay. If possible. So limit to k into f of x as x tends to a is nothing but k into limit to f of x as x tends to a. Okay. Now what is that next? F of g of x. It means that function of x, that is called the composite function. That is called the composite function. So if there is composite function, how to apply the limit as x tends to a? So we apply the limit to their term of x only. So you have to take outside limit to g of x as x tends to a. Okay. So if there is composite function, so we apply the limit to the term of x only. Okay. Now, what is that next? Limit to f of x as x tends to a is equals to f of a. Condition is that if function of x is continuous at x is equals to a. Function is continuous at x is equals to a. Means without break, every time there should be value of function. Am I right? So that is called the continuous. Function should be continuous, not breakable function. Am I right? So limit to f of x as x tends to a is f of a when function is continuous at x is equals to a. Okay. See the next. So here in limit, there are some simple results. Okay. So what are the results in the limit? So limit to sin x upon x as x tends to 0, it is 1. And now in last already I have discussed with you how to get their 1 for their function sin x upon x as x tends to 0. So what is that actual limit for this function? You observe it. When you substitute there x is 0, sin 0, it is 0. Upon 0, it is 0. 0 upon 0, yes. What is value of that? Terms 0 by 0. Yes, anyone? Can you guess their value of 0 by 0? Anybody? Anybody? सांगू शकाल का तुम्ही 0 upon 0 ची व्हॅल्यू काय असेल? Yes, what is that value of 0 by 0? Yes, anybody is interested to tell me?
Undefined.
Huh?
Undefined.
Yes?
Undefined.
Undefined. Yes, it is called indeterminate. Yes, of course, you are correct. It is, we can say, indeterminate. Am I right? मग जर ही व्हॅल्यू इनडिटर्मिनेट असेल तर 0 by 0, will you cancel their 0 from numerator and denominator? Yes, anybody? So what kind of quantity we can cancel from numerator and denominator? What is that basic criteria to cancel their terms from numerator and denominator? Yes, anybody? काय असेल रे? The term should be non-zero. कळलं का? म्हणजे फॉर एक्झाम्पल यू नो हियर 2 upon 2. We can cancel there 2 by 2. 2 will cancel, get 1. Suppose 2 by 4. It is 1 by 2. But 0 by 0 we cannot cancel. For cancelling their terms from numerator and denominator, their terms should be non-zero. You got it? But we are getting here 0 upon 0. असं मिळतं. But you know here, the value of this function as x tends to 0, it is 1. You have written here, or in this formula there is 1. But how you are getting there 1? Yes, how you are getting there 1? Will you write their solution 0 by 0? No. It is indeterminate or undetermined. Am I right? So need to find that finite value. And we get this finite value with the help of L'Hospital rule or by using expansion of sin x. So you have studied here the various kind of functions in power of x, or maybe you will study in this semester in the topic of expansion, how to expand there any type of function in powers of x with the help of Maclaurin's series, Maclaurin's expansion, and also by Taylor's expansion. It's very simple, no doubt. If you have any type of function, we can expand in powers of x. You got it clearly? कोणत्याही टाईपचं जरी फंक्शन असेल तर ते आपण फंक्शन पॉवर्स ऑफ एक्स मध्ये एक्सप्रेस करू शकतो. नाउ यू नो हियर what is that simple way to get here 1 when limit as x tends to 0? बघा. So what is that L'Hospital rule? You will study. You have to study that same. Where in this semester, in which topic? In the topic of indeterminate form. And this topic is totally based on L'Hospital rule. Okay. So when or where in which kind of limits we can apply that L'Hospital rule? So what is that L'Hospital rule? When the limit is in the form 0 upon 0. So in this case, taking derivative of numerator and denominator separately, not to apply their quotient law and difference. You got it clearly? Yes, is that clear? म्हणजे बघा साइन एक्सचं डेरिव्हेटिव्ह घ्यायचं. साइन एक्सचं डेरिव्हेटिव्ह काय मिळणार? कॉस एक्स अपॉन एक्सचं डेरिव्हेटिव्ह काय मिळेल? 1. आणि वेन अप्लाय द लिमिट ॲज एक्स टेंड्स टू 0, कॉस 0 ची व्हॅल्यू काय असणार? 1. आणि अपॉन 1 म्हणजे काय मिळणार आहे? 1. आर यू गेटिंग their limit as 1? Yes, is it clear? It's very simple. समजलं? जर तुम्हाला लिमिट 0 upon 0 मिळत असेल या इन्फिनिटी अपॉन इन्फिनिटी मिल रहा है, so in this case need to apply their L hospital rule. Okay, L hospital rule. And what is that L hospital rule? If limit of function is in the form 0 upon 0 or infinity upon infinity, at the same time taking derivative of numerator and denominator separately till finite form. ओके, मतलब जब तक आपको फाइनाइट लिमिट नहीं मिल रहा है तब तक क्या करना, ये यल हॉस्पिटल रूल अप्लाई करना. बट बेसिक क्राइटेरिया इज देयर टू अप्लाई द यल हॉस्पिटल. The limit should be in the form of 0 by 0 or infinity by infinity. In other cases, we are not using that L hospital rule. For example, infinity raised to infinity. So it is index in indeterminate form. So we cannot apply the L hospital. 0 raised to 0, we cannot apply that. Yes, infinity minus infinity, we cannot apply that. Am I right? We can apply the L hospital rule in which place the limit is in the form 0 upon 0 or infinity upon infinity. Okay. So same is there in tan x upon x as x tends to 0. आता बघा इथे. Here in this you have written 1. So when you apply the limit in actual function x is 0 and tan 0, what is that value of tan 0? Tan 0 ची value काय असते सांगा रे? What is that value of tan 0? What is that value of tan 0? Anybody has their value of tan 0? Yes? Can you tell me? अरे कोणी सांगू शकतं का तुमच्यापैकी? Tan 0. If you know their simple things, yes, it's very easy to study the subject of engineering mathematics. There are so many applications. Now in first year engineering, you have to study their basic things which acts as a fundamental for next 3 years. That I told you already. Okay. मग tan 0 ची value काय असेल रे? What is that value of tan 0? Yes, anybody has their value of tan
0.
0? Please.
0.
Yes.
Tan 0 is value 0.
Yes, you are correct. Absolutely. Means tan 0 is 0. X ची value काय असणार? 0. आणि 0 upon 0, it is also indeterminate. We have got in their previous function. Okay. So when limit is in the form 0 by 0, again you apply the real hospital rule. Real hospital means tan x the derivative. Do you know the derivative of tan x? Yes, anybody has? Anybody has their derivative of tan x? कोण सांगू शकतं का? Tan x चा derivative काय आहे रे? What is the derivative of tan x? Just I am discussing with you their things those you have studied in their 12th standard. Not to
Sir, sec square x.
Yes, of course. Sec square x. You are absolutely correct. Sec square x upon x चा derivative 1 असेल. बरोबर आहे ना? आणि when you apply their limit as x tends to 0 to sec square x, म्हणजेच कसं लिहिणार तुम्ही सांगा? sec square 0. sec square 0 म्हणजे काय रे? 1 upon cos square 0. आणि cos 0 ची व्हॅल्यू काय असते सांगा रे? What is that value of cos 0? Yes, anybody? Anybody has value there?
1.
Yes, of course. Cos of 0 is 1. And 1 square means what?
1.
What is that 1 square? 1 square. 1, of course. Yeah, will you write there 11? No. It is 1. मग काय मिळाली सांगा व्हॅल्यू? 1 मिळाली. You got it, no? Yes. Their way is simple to get there. Sometimes you are not knowing how their limit is 1 for these kind of functions. So we get their limit for these kind of functions by using their L hospital. So it is applicable only for the limit which is in the form 0 by 0 या infinity by infinity. You come in there next. आता sin inverse of x upon x आहे. Limit as x tends to 0. Sin inverse of 0. काय असणार आहे sin inverse of 0? What is that sin inverse of 0? Yes, anybody? आता मला तुम्ही सांगा sin 0 ची व्हॅल्यू काय असते रे? What is that value of sin 0? Yes, please. You tell me. What is that sin 0? Sin 0 ची व्हॅल्यू? Sin 0 is 0. Yes. Sin 0 काय असेल? 0 असेल. Okay. साइन 0 इज 0. ओके, मग साइन 0 जर 0 असेल तर 0 इज इक्वल्स टू साइन इनवर्स ऑफ 0 म्हणू शकता ना तुम्ही. इज दॅट क्लिअर? साइन 0 इज इक्वल्स टू 0 म्हणतात. मग 0 इज इक्वल्स टू साइन इनवर्स ऑफ 0, म्हणजे साइन इनवर्स ऑफ 0 ची व्हॅल्यू काय असणार? 0 असणार. इज दॅट क्लिअर? येस. आपण एक्स ची व्हॅल्यू काय लिहिली? 0 लिहिली. मग पुन्हा काय लिमिट मिळतं आपल्याला? 0/0 असं लिमिट मिळतं. आणि 0 जर 0 असेल तर इट इज वन्स अगेन इनडिटर्मिनेट फॉर्म. इज दॅट क्लिअर? Is that clear? It is once again in indeterminate form, like 0/0. So need to apply the real hospital rule. So real hospital rule said that taking derivative of numerator and denominator separate. आता sin inverse of x चे derivative काय असेल? What is the derivative of sin inverse of x? You know all these things. I am not asking to you their new things. I am asking only their old things, and old is gold. This is very simple thing. Simple. This is very simple, no doubt. If you know all these things, means what? You are enjoying their subject of mathematics. Yes, everyone. Sin inverse of x. What is the derivative of sin inverse of x? Anybody?
1/√1 minus x square.
Yes, 1/√1 minus x square. Is it clear? So 1/√1 minus x square. Yes, it is correct. Of course, you are correct. Now, upon derivative of x काय असेल? It is 1. Means need to substitute their value of x is 0, where in 1/√1 minus x square. म्हणजे x च्या ठिकाणी 0 टाकले, 0 square 0, 1 minus 0 1, √1 1, and 1/1 1. Means are you getting there 1? Yes. You can try for these kind of functions after completing this lecture. Definitely you will get their same. Okay, you try it, and if there is doubt you can ask personally to me. Am I right? No doubt. See here, what is that next? 1 plus k upon x raised to x as x tends to infinity. It is e raised to k. Suppose there is 1 by x. 1 plus 1 upon x raised to x as x tends to infinity. काय म्हणाला? e raised to k. So these are the standard format. We get their e raised to k, yes, by using their log and L'Hospital. So already you know there, when functions are in index form and suppose you are applying their limit, in this case, yes, need to apply their, yes, concept of log, taking log on both the sides, and then you apply their L'Hospital rule, and from this you will get their e raised to k. Okay, what is that? E raised to x as x tends to 0. So x is 0, a raised to 0, it is 1, and this is what the index log. This is what the index log. Okay, आता बघा next, tan inverse of x upon x as x tends to 0, it is also 1. How it is 1? You know, here you come in this function tan inverse of x. आता x च्या ठिकाणी 0 ठेवला. tan inverse of 0 काय असेल? What is that tan inverse of 0? You first of all you tell me tan 0. What is value of tan 0?
1.
Yeah, no, it's wrong. Tan 0 बघा मला सांगा तुम्ही. Tan 0. Tan 0
Zero.
sin 0 upon cos 0. Am I right? Tan 0 आपण कसं लिहितो सांगा? Sin 0 upon cos
0.
Yes, 0. Of course. Sin 0 ची व्हॅल्यू 0 अपॉन cos 0 ची व्हॅल्यू 1. म्हणजे 0 upon 1 काय होणार आहे? 0 असणार आहे. 0 divided by any finite number is 0. But any finite number divided by 0, it is infinity. That you should keep in mind. मग tan 0 जर 0 होत असेल तर 0 is equals to tan inverse of 0. You can shift their function from left to right or right to left. So when you transfer their function from left to right for tan, their tan will become tan inverse. So 0 is equals to tan inverse of 0. म्हणजे tan inverse of 0 ची व्हॅल्यू काय असणार आहे? 0 अपॉन x टेन्स टू 0. इथं सुद्धा काय करायचं? 0 सबस्टिट्यूट करायचं. म्हणजेच काय मिळतं 0/0. Once again we are getting their 0 value. Okay, and if limit is in the form 0/0, again you have to apply the L'Hospital rule. And what is that L'Hospital rule? Taking derivative of numerator and denominator separately. Yes, not to apply the quotient law. Yeah, division law in differential. Tan inverse of x. Anybody has the derivative of tan inverse of x?
1 plus x square.
Yes, of course it is correct. Is it clear? So 1/1 plus x square असं मिळेल. आणि आपण derivative of x काय मिळेल? 1. Means only to substitute there x tends to 0 as a limit in 1/1 plus x square. मग x या ठिकाणी 0 टाकला 0 square 0. 1 plus 0 1 and 1/1 1. Are you getting that same? It is also 1. Just I am discussing with you their simple results. Sometimes you are not knowing how you are getting their values for limit of various functions. Okay. आता in means what? Log. That's meaning काय बघा? Log. Log of 1 plus x. हा natural log आहे. In means what? Natural log. And in natural log, what is that base? What is that base? Exponential. You got it, na? What is that base? Exponential is the base of natural log upon x. आता बघा, when I apply the limit as x tends to 0, मला सांगा log of 1 plus 0 to the base e and log of 1 to the base e काय मिळणार सांगा रे? It is 0 and log means what? Is nothing but to express the power. आता फॉर एक्झाम्पल बघा, e raised to 0 is equals to 1 लिहितो, बरोबर आहे ना? मग हे लॉग मध्ये आपण कसं लिहितो सांगा? log of 1 to the base e is 0, बरोबर आहे ना? म्हणजे log of 1 to the base to any base it is also 0, म्हणजे हा 0 अपॉन x टेन्स टू 0 म्हणजे हा सुद्धा 0 झाला. म्हणजेच काय मिळालं? 0/0. You got it? Yes. So taking derivative of numerator as well as denominator separately, and this is by index, this is by L'Hospital. What is derivative of log of 1 plus x? Anybody? Do you know there are derivative of log of 1 plus x? First of all, you tell me what is derivative of log x to the base e? Yes, anybody has? Derivative of log? Derivative of log?
1/x.
1/x. Yes.
1/.
Yes, correct. Of course. So it is 1 by x. And derivative of log of 1 plus x काय मिळणार आहे? So it is 1/1 plus x, no? Is that clear? Yes? Is that clear? Log of 1 plus x. What is the derivative? 1/1 plus x. And again to find the derivative of 1 plus x with respect to x means what? Getting 1. म्हणजेच काय डेरिव्हेटिव्ह मिळतं? 1/1 plus x. Upon derivative of x काय मिळेल? It is also 1. So need to apply the limit to function 1/1 plus x as x tends to 0. मग काय मिळणार सांगा रे? 1/1 plus 0 म्हणजे 1 आणि 1/1 not double 1. It is 1. Okay. So in this way we get there 1. आता नेक्स्ट बघा, इथं काय बघा? Limit as x tends to infinity to 1 plus 1 by x whole raised to x. It is exponential e. It is exponential e. It is exponential e. So you know here, this is what the index function. If there is index function, and when you apply the limit as x tends to infinity, बघा काय होणार? 1 plus 1/infinity. What is that 1 by infinity? Yes, anybody? What is that 1 by infinity? What is value of 1 by infinity?
Not defined.
1/infinity. Infinity is not defined. That
0.
Yes, 1/infinity is yes, correct.
0.
0. Yes, it is 0. आता तुम्ही म्हणाल हाऊ देअर व्हॅल्यू ऑफ 1 by infinity is 0. You get their meaning of infinity. Infinity means what? What is your guess for infinity? You will say here not defined. It is first meaning. What is the second meaning of infinity? Yes, from you side, you tell me. It's very simple, no doubt. What is your opinion for their meaning of infinity? So first of all, it is not defined. That I can understand, no doubt. What is for next? Infinity means what? It is figure with number of digits. You got it? Maybe 1 lakh, 100. Means uncertain figure is there. Am I right? Uncertain maximum figure. ती काय असते? Uncertain maximum figure. Is that clear? Yes? Uncertain maximum figure. Maybe 1 lakh, 2 lakh, 1 million, 2 billion, and so on, etc. Uncertain. Okay? Not defined. Okay. आता मला सांगा 1 upon infinity. Here in this way of what? 1 upon infinity. Means 1 divided by, for example, 100. 1 divided by 100 आप कैसे लिखते हो रे? 0.01. 1 divided by 1000 आप कैसे लिखते हो? 0.001. 1 divided by 1 lakh आप कैसे लिखते हो? 1 lakh means what maximum figure is there? So 0.00001. You got it? Means their quantity becomes a negligible. That is 0, equivalence to 0. You got it, everyone? 1 upon infinity is 0. 1 upon infinity becomes a 0. Suppose you are taking their value of infinity as a figure with number of digits. You will get their negligible quantity, that is equivalence to 0. And 1 plus 0 is what? What is that 1 plus 0? It is 1. 1 plus 0, it is 1. And 1 raised to काय मिळते? Infinity मिळते. What is that 1 raised to infinity? What is that 1 raised to infinity? Anybody has their value for 1 raised to infinity? Can you find this value by Kelsey? Will you get their value of 1 raised to infinity by Kelsey? Anybody? Can you get their value? 1 raised to infinity. Yes, anybody? Please, you tell me. 1 raised to infinity. काय म्हणणार सांगा? What is that 1 raised to infinity? And do you know their meaning of infinity? Infinity is nothing but figure with number of digits. We can say it may be 100.
Infinity.
Yes?
Infinity.
No. 1 raised to infinity, again it is indeterminate form. You got it? Na? See here. 1 raised to 0 of 1 लिखते हो. लेकिन 1 raised to infinity, it is again an indeterminate form. So what are the indeterminate forms? 0 raised to 0. It means that it doesn't have a specific meanings. Hence, we can say these are indeterminate form. Your try is best, no doubt. So 1 raised to infinity is what? Indeterminate form. Means what? It means what? It doesn't have a specific meaning. Okay? So 1 raised to infinity, or like infinity raised to infinity, 0 raised to 0, infinity minus infinity, these all are indeterminate form. Also 0 by 0, infinity by infinity. Okay, so these all are indeterminate form. These all are indeterminate form. So here in this we have studied their function and also the results. So these results are important to study their examples in first year engineering. Am I right? So first year engineering acts as a fundamental. It means that everyone should have the strong fundamentals, that is basic things which you have studied in their 12th standard. Okay? Which you have studied in their 12th standard. So anybody has doubt in this connection? Yes, anybody has doubt? Do you get their understand? Do you get their clear understanding? Yes, anybody? So if you have doubt, anybody has doubt, you can ask on my personal WhatsApp number. Okay, so I will provide to you their solution. Okay.